3:10 p.m., April 27th, 2011. A family in rural Mississippi films a strange cloud a mile away. 5 minutes later, their home no longer exists. The tornado that struck them would go on to carve a path of destruction so complete it left a scar on the Earth visible from space. For years, scientists believed this was an act of raw power, but recent soil analysis from the damaged path reveals it wasn't just wind. It was something far more terrifying. This is the story of Philadelphia. Neshoba County, Mississippi sits at the heart of what meteorologists call Dixie Alley, a region known for producing some of America's most violent tornadoes. Philadelphia, the county seat, with a population just over 7,400, had weathered its share of storms since its establishment in 1833. The town had learned resilience through hardship, from the Civil War to economic depressions to previous tornado events. But nothing in its history would prepare residents for what April 27, 2011 would deliver. The day marked the culmination of the largest, most violent tornado outbreak ever recorded. For 3 days, supercell thunderstorms marched across the southeastern United States, spawning 362 confirmed tornadoes that would claim 324 lives. By the afternoon, on April 27th, Alabama had been ravaged, with major cities like Tuscaloosa suffering catastrophic damage. Mississippi meteorologists watched with growing concern as atmospheric conditions deteriorated to unprecedented levels. The Storm Prediction Center in Norman, Oklahoma, had issued a rare, high-risk outlook for severe weather, their most dire forecast for the fourth consecutive day. Meteorologists noted convective available potential energy, known as CAPE, values exceeding 4,000 joules per kilogram, indicating extreme atmospheric instability. Combined with wind shear values approaching 80 knots, the ingredients were assembling for what one forecaster described as the perfect recipe for long-track violent tornadoes. Philadelphia had experienced deadly tornadoes before. In 1966, a significant tornado struck the town, killing 7. But historical records revealed no precedent for what was brewing on radar screens that afternoon. The same supercell thunderstorm that had produced the devastating EF5 tornado that struck Hackleburg and Phil Campbell in Alabama was regenerating as it crossed into Mississippi, feeding on the unstable air mass ahead of it, like a predator sensing weakness. At 3:05 p.m., storm spotters reported a wall cloud formation northwest of Philadelphia. The National Weather Service issued a tornado warning at 3:07 p.m., with radar indicating strong rotation. But technology could not convey the true nature of what was developing. The vortex touched down at 3:12 p.m., near the intersection of Highway 21 and Road 505. Within 90 seconds, what began as an EF1 tornado with winds around 100 miles per hour underwent explosive intensification, a phenomenon meteorologists call rapid tornado genesis. By 3:15 p.m., as it approached the small community of Sebastopol, the tornado had transformed into a multi-vortex monster with a damage path nearly a mile wide. The effect was apocalyptic. Conventional tornadoes damage structures through differential pressure and wind force. The Philadelphia tornado did something meteorologists rarely witness. It created a ground-level scouring effect that stripped the Earth bare. The National Weather Service survey team would later document something unprecedented. Areas where not only were homes swept completely clean from their foundations, but several inches of soil and vegetation were removed, leaving nothing but exposed bedrock in some locations. Dr. Timothy Marshall, a forensic engineer who surveyed the aftermath, explained that this was not just wind damage. The tornado created a vacuum effect combined with incredible rotational velocity that literally peeled the ground away. His team found evidence of sustained ground-level wind speeds approaching 250 miles per hour, beyond what our instruments are designed to measure. The tornado maintained enhanced Fujita 5 intensity for 17 miles of its 29-mile path, a duration almost unheard of in tornado science. Pine forests that had stood for decades were not simply snapped, they were entirely debarked and shredded, with some trees completely uprooted and carried hundreds of yards. The timber industry in Neshoba County suffered losses exceeding $20 million from this single event. Infrastructure collapsed under the tornado's assault. A 230 kilovolt transmission line with steel reinforced towers, designed to withstand winds of 140 miles per hour, was demolished, with towers twisted and collapsed like tinfoil. Highway 21, a major thoroughfare, was scoured down to its concrete base in sections, with the asphalt completely removed. Particularly horrifying was the tornado's effect on structures. Frame homes were not just damaged, they were completely obliterated, with debris ground into pieces so small that property owners could not identify remains of their possessions. In one case, a 3,000 square foot brick home was reduced to a bare foundation, with debris scattered over 2 miles downwind. The family's sport utility vehicle was later discovered embedded in a hillside nearly a half-mile away, compressed to roughly one-third its original size. James Williamson, a 64-year-old resident whose home was destroyed, said he had lived through hurricanes in Florida and tornadoes in Oklahoma, but he had never heard anything like this. It was not the freight train people talk about. It was like the sound of the world ending, a constant grinding roar that seemed to come from inside your head as much as outside. Karen Williams and her family, who captured some of the only video footage of the tornado's early development, described the surreal experience of watching nature transform before their eyes. She recalled that it formed so fast. 1 minute it was a dark cloud, the next it was this massive, churning wall moving with purpose. It seemed to be following the highway like it knew where it was going. They said they had about 2 minutes to get to their storm shelter before it hit. First responders arriving at the hardest hit areas described scenes of total devastation that defied comprehension. Deputy Sheriff Marcus Johnson was among the first emergency personnel to reach the tornado's path near Highway 16. He said he had worked disaster scenes for 15 years and had never seen anything like it. It was not just that homes were gone, it was like they had never existed in the first place. He said they found a refrigerator wrapped around a tree trunk half a mile from where it started, and he asked how you even process that kind of power. Storm chaser Reed Timmer, who intercepted the tornado near its dissipation point, described it as the most violent circulation he had documented in his career. His instruments recorded barometric pressure drops exceeding 100 millibars in less than 30 seconds as the tornado passed nearby, readings that approach theoretical limits for tornadic vacuum effects. Perhaps most chilling were accounts of the tornado's visual appearance. Multiple witnesses described not seeing the classic funnel shape, but instead what meteorologists call a wedge tornado, a massive dark wall of debris that obscured the actual circulation. Neshoba County resident David Hollingsworth recalled that it was just this black wall moving across the landscape, eating everything in its path. You could not see through it or around it. It was like watching a piece of the night come alive. The tornado's multi-vortex structure created bizarre damage patterns that confounded investigators. In one documented case, a home was completely destroyed, while the detached garage 30 feet away remained virtually untouched. In another instance, a child's plush toy was found embedded in a concrete wall, physical evidence of winds capable of turning ordinary objects into bullets. The Mississippi Emergency Management Agency, MEMA, activated its Emergency Operations Center within minutes of the first reports of catastrophic damage. Governor Haley Barbour declared a state of emergency for Neshoba and surrounding counties by 5:30 p.m., mobilizing National Guard units to assist with search and rescue operations. First responders faced extraordinary challenges. The tornado had severed major transportation routes, destroyed communication infrastructure, and scattered debris across miles of rural landscape. Conventional GPS navigation became unreliable as landmarks had been erased. Search teams had to use paper maps and compass navigation to locate isolated properties where residents might be trapped. Fire Chief James Wilson explained that they could not use the roads because they were either gone or blocked, and they could not use cell phones because towers were down. He said it was like trying to coordinate a rescue operation in a war zone, except the enemy had already come and gone, leaving nothing but devastation. The Philadelphia National Guard Armory became an impromptu command center and shelter, housing over 200 displaced residents the first night. Damage assessment teams documented complete destruction of 76 homes, major damage to another 169, and minor damage to over 300 structures. Infrastructure losses included 4 destroyed electrical substations, 7 severed water mains, and 22 miles of roads requiring major repairs. Medical response was complicated by the tornado's direct hit on the Neshoba County Medical Center, which sustained significant roof and structural damage. Emergency medical services established field triage stations, treating over 80 injuries ranging from minor cuts to critical trauma cases. 8 fatalities were confirmed, a number that experts agree would have been significantly higher had the tornado struck more densely populated areas. Recovery operations faced a unique challenge. The tornado had scattered debris so widely and ground it so finely that traditional cleanup methods proved ineffective. Specialized environmental teams had to be brought in to address concerns about pulverized building materials, including asbestos from older structures, contaminating soil and water supplies. FEMA coordinator Robert Latham said this was not a normal cleanup situation. He said that in many disaster areas you can identify what used to be a house or a barn. Here, we found areas where everything was just gone. Pulverized. We had to develop new protocols for soil testing and environmental remediation on the fly. The Philadelphia tornado forced meteorologists to confront uncomfortable truths about tornado classification and public safety messaging. The enhanced Fujita scale, used since 2007 to rate tornado intensity, topped out at EF5 for winds exceeding 200 miles per hour, but the Philadelphia tornado produced evidence of speeds approaching 250 miles per hour, far beyond what existing damage indicators could reliably measure. Dr. Joshua Werman, founder of the Center for Severe Weather Research, explained the significance. He said, "We have suspected for years that the most violent tornadoes might exceed the upper bound of our classification system, but Philadelphia gave us physical evidence. The soil scouring patterns, coupled with radar observed rotational velocities, suggest we may need to reconsider how we communicate the true destructive potential of these rare events." The tornado prompted innovations in both forecasting and warning systems. The National Weather Service implemented new radar analysis algorithms specifically designed to detect the rapid intensification patterns observed in the Philadelphia event. Warning language was revised to include more specific descriptions of expected impacts rather than simply wind speeds. National Weather Service meteorologist Gary Woodall explained, "Before Philadelphia, we might have said a tornado was capable of causing catastrophic damage. Now, we are more likely to say this tornado will make neighborhoods unrecognizable and survival unlikely outside of reinforced shelters. It is blunter, but research shows people respond better to concrete impact descriptions than abstract threat levels." Community resilience strategies evolved as well. Neshoba County implemented a comprehensive storm shelter program, installing 28 public shelters and subsidizing private shelter construction. Building codes were updated to require enhanced anchoring systems for new construction, with special attention to the ground level connections that had catastrophically failed during the tornado. Perhaps the most significant scientific legacy came from forensic analysis of the damage path. Researchers from the University of Oklahoma used high-resolution mapping techniques to document the tornado's scour signature, places where soil had been completely removed. This data led to new understanding of how extreme tornadoes interact with the ground, generating secondary circulation patterns that amplify destruction. The scour patterns were especially revealing. Dr. Howard Bluestein, a pioneer in tornado research, explained, "What we learned from Philadelphia changed how we model tornado dynamics. We discovered that at certain wind speeds, the interaction between the vortex and the ground creates what we now call excavation currents, upward directed flows that can literally lift the soil away. This explains damage patterns that previously seemed physically impossible." The tornado's legacy extended to emergency management protocols. The challenges faced by first responders led to the development of new search and rescue techniques specifically designed for catastrophic tornado events, including drone-based thermal imaging systems that can detect survivors beneath debris, and satellite-based damage assessment tools that function even when ground infrastructure is destroyed. For the scientific community, Philadelphia became a reference point, a benchmark for what represents the upper limit of atmospheric violence. When meteorologists today discuss potential tornado threats, Philadelphia-type conditions have become shorthand for the most extreme scenario possible. The residents who rebuilt after the tornado incorporated their hard-won knowledge into new homes and businesses. Underground storm shelters became standard features. Community warning systems were enhanced with redundant notification methods. The scars on the landscape have largely healed, covered by new growth, but the memory remains embedded in local consciousness, a reminder of nature's capacity for both destruction and renewal. In Meteorological Archives, April 27, 2011, stands as the day when science confronted the raw edge of what our atmosphere can produce. The Philadelphia tornado rewrote the boundaries of what we thought possible and forever changed how we prepare for, respond to, and recover from nature's most violent expressions. If you found this deep dive into one of history's most extraordinary tornadoes informative, hit the subscribe button and join the Tornado Attacks community. We are dedicated to bringing you the most thoroughly researched extreme weather stories on YouTube. Leave a comment with other historic tornado events you would like us to investigate, and do not forget to share this video with anyone fascinated by the raw power of nature. Until next time, stay weather aware, and remember, knowledge is your best shelter.